Okay, good everyone. Welcome to my class. Today we're going to discuss indices. Indices is a plural form of the word index. And the word index means power or exponent. So indices is the value through which a number or an expression is raised. For instance, x power n, this is an indical expression, indices, where your x is your base and your n is your power or index or exponent. Now, x power n means that x is multiplying itself n times. X is multiplying itself n number of times. That is x times x times x times x times x up to what? N times. So x power 5 means what? X is multiplying itself 5 times. X times x times x times x times x. 1, 2, 3, 4, 5. X power 2 means what? X is multiplying itself twice. X times what? X. Now we move to the laws of indices. There are several laws of indices, and we're going to take them one by one. The first one is the product law. Let x be not equal to 0. Then x power a times x power b. According to the product law of indices, when multiplying similar bases will sum up their exponents. The basis here is what? Is x, and the basis here is what? Is f. They are the same. So when multiplying similar bases, we sum up their exponents. So these are the exponents a and b. These are similar, so x. The exponent is what? A plus b. This is the product law or the multiplicative law of indices. Let's take these examples. X power, let's make use of numbers, not longer variables a and b. X power 2 times x power 5. Are the bases the same? The bases are the same, x. So since the bases are the same, we sum upward the exponents. So 2 plus 5, which is equal to x power 7. Or we can expand x squared, which is what? X multiplying itself twice, and x power 5. X multiplying itself 5 times x times x times x times s. 1, 2, 3, 4 times x. Now we sum up the powers of x. The powers of x here is what? 1, 1, 1, 1, 1, 1, 1. So 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1, 5 plus 1, 6 plus 1, 7. We have x power 7. Then let's take another illustration. Let's call this I. Example I. Then we have 10 power 2 times 10 power 3. Now, what is the base here? The base in this equation is 10. Are the bases the same? Yes. 10, 10. 10 squared times 10 cubed. So 10. Then what is are we going to do next? Is to sum up the power. So 2 plus 3, which is equal to what? 10 power 5. Let's take more examples. Example I. A power 3 times a power 9. Are the bases the same? Yes. The basis here is what? A and A. So A. So since the bases are the same, we can now sum up the exponents. So 3 plus 9, which is equal to a power 12. I hope this is very clear. And we move to, let's take another examples involving real numbers. IV 2 squared times 2 power 4. Are the bases the same? Yes. Yes. Then, since the bases are the same, we sum up their exponent according to this law, the product law of indices. So 2 plus 4 is equal to 2 power 6. Next, we move to the division law of indices. Okay, let's make use of this place. The division law. Let's take this illustration. X power A divided by X power B. The division law of indices says that when dividing two expressions which have similar bases, we subtract their exponents. But for multiplication, similar bases multiplying, we add what? Exponent. But for division, we subtract their exponents. So we have x power a minus b for division. And 2 divided by 3 can be written as what? 2 over 3. So x power a divided by x power b can be written as x power a over x power b. And this can also be simplified to x power a times 1 over x power b. And 1 over x power b is equal to x power minus b. Inverse is the inverse notation. Now, applying the law of multiplication, the product law, multiplying similar bases, we add their exponents. So x power a plus minus b, and plus times minus. According to BODMAS, bracket is multiplication. So plus times minus is what? It's minus. So I have what? X minus b, which is equal to this. Now let's take our examples. (22) example I under the division law. 22 n power 7 divided by 2n cubed. Now this can be written as 22 n power 7 over 2n cubed. Now 22 divided by 2 is 11. Then I have n power 7 and also what? N cubed. According to division law of indices, so long the bases are the same, you subtract their powers or exponents. So I have 11 n power 7 minus 3, which is equal to 11 n power 4. Or I can decide to expand my n power 7 and n cubed. So I have 11 times n, and let's multiply itself up to 7. So n times n times n times n times n times n times n all over n cubed. So n cancel out n cancel out n cancel out n. How many n's are left? 1, 2, 3, 4. So I have what? 11 n power 4. I hope this is clear. Now we take another example. Example II. S cubed divided by x power minus 5. So I'm having, are the bases the same? Yes. So I have x 3 minus 5. I have x cubed. When dividing similar bases, you subtract then this other power minus what? 5. Now we have x cubed minus times minus is plus 5. So I have x 3 plus 5 is what? 8. So we are through with the division law. Alright, so next we move to the zero power of indices. Zero power, x power 0. Any number to the power of 0 is equal to 1. Why? Now, 8 minus a is equal to 0. A number subtracting itself is equal to what? 0. Then we have x power a minus a. Alright? Now, according to indices, the multiplicative rule, this can be written as x power a plus minus a. Hence, x power a times x power minus a. Now, I have x power a times 1 over x power a. X power a times 1 is equal to x power a over x power a, which is equal to 1. So any number to the power of 0 is equal to 1. Then we move to the negative index. Negative index, which is the fourth law. Negative index. X power minus a is equal to 1 over x power a. 1 over 2 is equal to 2 power minus 1. 1 over x is equal to what? X power minus 1. This is the index law of indices. Hence, let's take this example as an I. 5 power minus 2 is equal to 1 over 5 square is equal to 1 over 25. And index, the negative index means reciprocation. Now, as you have seen, 1 over 2 power minus 1 is equal to what? 1 over 2. Reciprocation. If I have a over b power minus 1, what is my answer? Is b over a. Reciprocation. So a over b is equal to b over a. So long a over b is raised to the power of minus 1. So turn something upside down. That's what we mean by reciprocation. Now, let's take some examples. Let's take examples. So, 2 cubed times 1 over 6 power minus 1. So 2 cubed times 1 over 6 power minus 1 is what? Actually what? Reciprocate 1 over 6, which is what? 6 over 1. So we have 2 cubed times 6, because any number over 1 is that same number. So 2 cubed is what? 8 times 6. And 6 times 8 is equal to 48. Let's take further examples. I. So I. Here I have 9 a power minus 5 times 4 a power 6. So I have, first of all, we have to solve this. 9 times 4 is 36. And I have a power minus 5 times a power 6. Now 36, this is equal to a power minus 5 means to reciprocate a power 5. So I have 1 over a power 5 times a power 6. Obviously, it's from the division law of indices. A power 6 divided by a power 5, because 1 times a power 6 is a power 6. So a power 6 divided by a power 5. So a power 6 minus 5 is equal to what? A. Hence, I have 36 a power 6 over a power 5 is equal to 36 a power 6 minus minus what? 5. I have what? 36 a just a power 1, which is 36a. Hope it's clear. Let's take more examples on the negative index or negative power or negative exponent of indices. X cubed times x power minus 5. Okay, so we have x cubed times 1 over x power 5, right? I have s cubed over x power 5 which is equal to x cubed minus x power x cubed minus 5, which is equal to x power minus 2. Or another example, x cubed, let's see, this is 4. X cubed divided by x power minus 5. Now, we have x cubed divided by 1 over x power 5. Right? So this can be written as x cubed divided by 1 over 1 divided by 1 over x power 5. X cubed divided by all this expression is the same as this. Now we have what? X cubed over 1 times x cubed power 5 over what? 1. We now reciprocate 1 over x power 5. We have this. Divisions, and this is where it comes in. Yes. For us to solve this, we introduce multiplication. We eliminate this division by introducing multiplication and reciprocating 1 over x power 5. Then we have x cubed over 1 is the same as what? X cubed, right? Times s power 5 over 1 is the same as s power 5, right? So from the multiplicative law of indices, I'm multiplying similar bases with some of their exponents. So we now have x power 3 plus 5, which is equal to x power 8. Straightforward and simple. Now, next we move to the power law. The power law. For instance, this is the fifth one now. The power law. Fifth law. Power law. For instance, let's take example 1. I have x power a all power b. This means that x power a all power b. The b is multiplying all the powers inside the bracket. All powers inside the bracket. So I have what? X power a times b is equal to x power a b. I have x power 2 multiplying just cube. That is x power 2 all cube. This is equal to what? X power 2 times what? 3, which is equal to x power 6. If I have y squared x power 4 all power 6, this means that what? This 6 is multiplying each of the powers inside the bracket. So I have what? Y power 2 times 6, x power 4 times what? 6. And I have what? Y 2 times 6 is 12. Then multiplying x, 4 times 6 is what? 24. The power law of indices. Yes. So this is clear and straightforward. Let's take further examples. Let's take this example. 3 power minus 2 all power minus 2. So minus 2 is affecting everything, all the powers inside the bracket. So we have 3 power minus 2 times minus 2. We have 3 minus times minus is plus, and 2 times 2 is 4. So our answer is 3 power 4, which is equal to 81. Then we take minus 3 d cube, another example, all squared. So I have minus 3 squared d cube times 2. Minus 3 squared is what? Minus 3 squared is what? Is 9. And d power 3 times 2 is d power 6. And also, similar example, but in different way. Minus 3, the bracket, d cube all square. You see, you observe that in this question, the minus 3 is not inside the bracket, so minus 3 won't be squared. So minus 3 is outside, so to be left untouched. It will not be, this power 2 won't affect it because it's outside the bracket. So we have d cube times 2. Hence you have minus 3 d power 6. All right, so we've come to the end of the power law of indices. I hope this is clear. Let's take one more before we round it up. I call this extra. Then we have minus d power 5 power 4. You observe that the value here is minus 1. So we have minus 1 power 4 d 5 times what? 4. Minus 1 power 4 is what? Is 1. And d 5 times 4 is 20. Hence we have 1 times d power 20. Hence we have d power 20 as our answer. Minus 1 to the power of m has two values. If m is positive, or if n is even, your result will be what? Positive 1. But if n is odd, if m is odd, then your answer is what? Minus 1. In this case, we have minus 1 power 4. 4 is even, hence our answer is what? 1. But if we have an odd power, let's say minus 1 cube. Minus 1 cube is the same as minus 1 times minus 1 times minus 1. Minus 1 times minus 1 is what? 1. And 1 times minus 1 is equal to minus 1. So any odd power of minus 1 the answer is always what? -1. But to every even power of -1, the result is always what? 1. Alright. Now, fractional indices. Fractional indices, in other words, fractional powers or fractional exponent, x power a over b. Now, before I touch this, x power 1 over 2 is equal to root x. X power 1 over 3 is equal to the cube root of what? X. So x power 1 over n is equal to the nth root of what? Of x. But recall that x power 1 over 2 is equal to just what? The square root of x. So this is square root of x. We don't include the 2 here. But for 3 up to infinity, we'll keep what? Including what? The n value. For instance, x power 4 is equal to x power 1 over 4 is equal to 4 root of what? X. X power 1 over 5 is same as what? The 5th root of what? Of x. But for x power half, x power 1 over 2 is just what? Square root of x. Hope it's clear. So x power 1 over b is same as what? B root x. X power 1 over 2 is equal to what? Just what? Root x. Now, let's take this x power a over b is the same as writing what? The bth root of x all power a. Recall 1 over x power 1 over n is equal to n root of x. So x power 1 over b means what? The bth root of x all power a. I hope it's clear. Yes, it's very, very clear. Now, let's take more examples for understanding, for clarity. Okay, now 9 power half is same as what? Square root of 9, which is equal to what? 3, right? Power half means square root. Power half means what? Square root. So 9 power half means what? The square root of what? Of 9. And 8 power 1 over 3 is equals to what? The cube root of 8. The cube root of what? Of 8. Which is what? 2. 2 times 2 times 2 is equal to what? 8. So 2 cube is equal to what? 8. So the cube root of 8 is equal to what? 2. And 8 power minus 2 over 3 is the same as what? The cube root of 8 power minus 2, which is what? 1 over cube root of 8 power 2. And the cube root of 8 is equal to 2, right? So 1 over 2 squared is equal to 1 over 4. I hope it's clear. Yes. And let's take our final example under these fractional indices. So I have 16 over 81 power minus 3 over 4. as I taught you earlier on, when we have a negative index, you can reciprocate your expression. It's one will come at the top and 16 will come down. Reciprocation. So what are you left with? You're left with what? 3 over 4. The negative now disappears after the reciprocation. Now, from the power rule, I'm going to use this outer power to multiply each of the power inside the bracket. So I have 81 times it's 1 power 3 over 4 over 16 power 3 over 4. And this is equal to the fourth root of 81 all cube and what? The fourth root of 16 all cube. And the fourth root of 81 is what? Is 3, because 3 power 4 is equal to 81. 3 times 3 times 3 times 3 up to 4 times is equal to 81. So I have 3 power 3 over the fourth root of 16 is equal to 2, because 2 power 4 is equal to 16. 3 power 4 is equal to 81, so answer is 3. And 2 power 4 is equal to 16, so we have 2 all power 3. So 2 power 3 is equals to 3 power 3 is equals to 27. And 2 cube is equals to 8. So our final answer is 27 over 8. Hope it's clear. Yeah. Now let's take one more example on the indices. Now consider this example: square root of 72 a cube b power minus 2 over 2a power 5 b power minus 6. For us to solve this equation, we have to simplify term-wise. In other words, 72 over 2, the number to number, and letters to letters. Numbers toward number and letters toward the is corresponding like letters or variables. So you have 72 over 2, a cube over a power 5, and b power minus 2 over b power minus 6. You have to simplify by dividing term-wise. So I have 72 divided by 2 is what? 36. And I have a cube according to the division law of indices. When dividing similar bases, we subtract what? Their powers or exponents. So hence I have a cube minus what? 5. The same thing to b, I have b power minus 2 minus then minus 6. So I have square root of 36 a 3 minus 5 is minus 2, and I have my b minus 2 minus 6. Minus times minus is plus. So minus 2 plus 6 is what? Is 4. Now I simplify this and recall that the square root sign means power half, as in square root of x is equal to x power 1 over 2. So I have 36 a power minus 2 b power 4 all power half. Hence, according to the power rule, the power outside the bracket multiply all the powers inside the bracket by each term. So I have 36 power half multiplying a minus 2 power half multiplying b power 4 power half. Hence, let's go up. So 36 power half means the square root of 36, which is equal to 6. 6 times 6 is 36. So the square root of 36 is 6. So I have 6. Now, minus 2 times half. Minus 2 times half. 2 cancel out 2. What is left? Minus 1. So I have a power minus 1 and b power 4 times half. So 4 times 1 over 2. 4 times 1 over 2. 2 times 2 cancel out 4. 2 times, which is what? 2 times 1 is equals to what? 2. Or you can say 4 times 1 is what? 4 and over 2. So 2 cancel out 4, and that 2. So I have what? B power 2. So this is my final answer. Or I can say write this as 6b squared over what? A. Because of what? This negative index. So we've come to the end of today's lessons. Please do well to like, subscribe, and share this video. Thank you. Catch you next time.